Greetings, math detectives. Our mission today is to solve the equation x to the 1/2 equals 1. Before we jump into solving, let's establish the playing field for our variable x. What values can x actually take for this expression to make sense in the real numbers?
For x to the 1/2 to be a real number, x must be greater than or equal to 0. If x equals 0, the equation becomes 0 to the 0 to the 1/2, which simplifies to 0 to the 0. This expression is an indeterminate form and usually considered undefined. So to keep our numbers real and defined, x must be strictly positive.
Excellent! With our domain firmly set, let's consider the general rule for equations of the form a to the b equals 1. When the base a is positive, there are precisely two scenarios that make the equation true. Either the base itself is 1 or the exponent is 0. Let's investigate these two pathways.
Our first path leads us to the possibility that the base, x, is equal to 1. This is a wonderfully straightforward case. If x is 1, let's see what happens to our original equation. Does it hold true?
Plugging x equals 1 into our equation yields 1 raised to the power of 1 to the 1/2. This simplifies beautifully to 1 to the 1, which is indeed 1. This perfectly matches the right side of our equation. So we found our first real solution. Now, for our second path, what if the exponent, x to the 1/2, is equal to 0? This is another way to make an exponential expression equal to 1, as long as the base isn't 0. Let's solve for x in this scenario and keep our domain in mind. To isolate x from x to the 1/2 equals 0, we simply square both sides. This gives us x equals 0. But wait a minute. Remember our strict domain condition? We established that x must be greater than 0. Since x equals 0 does not meet this requirement, it cannot be a solution.
After carefully navigating both possibilities and respecting our domain, we've arrived at our grand conclusion. The only value of x that makes x to the 1/2 to the 1/2 equals 1 a true statement is x equals 1. Bravo, everyone. Bravo.